Hello friends, welcome to a lecture series on multivariable calculus. So in the last lecture we have seen that what do we mean by existence of a limit for two variable functions. We have seen that limit of two or more than two variable exist. This means that it is path independent. Whatever path we approach from xy to x0 y0, the limit if exist is always unique, that is it is path independent. Okay. And if we have to show that the limit does not exist, we try to show that from two different paths value of the limits are different. Now we will see what do you mean by continuity of multivariable functions. So a function fxy is said to be continuous at a point x0 y0 if these three properties hold. That means function is defined at x0 y0, limit xy tending to x0 y0 fxy exists, and limit xy tending to x0 y0 fxy is equal to f of x0 y0. And a function is continuous if it is continuous at every points of its domain. Okay. So, if you are talking about continuity at a point, so this means that limit xy tending to x0 y0 fxy should be equals to f of x0 y0. This means, this implies function f is continuous at x0 y0. So this means limit should exist, okay, and is unique. This means this value of the function should be defined at x0 y0, and the value of the limit must be equals to f at x0 y0. Okay. Then this means function is continuous at x0 y0, and if it holds for every x0 y0 in the domain of f, then we say that the function is continuous in the domain of the function f. Okay. Now we will see some examples based on this. Discuss the continuity of function following function at x0 y0. Say the first function we are taking, the function is it is x minus y whole square, x square plus y square when x y are not equal to 0 0, and it is 0 when x y are equal to 0 0. So function is defined at 0 0, and the value of the function is value of the function at 0 0 is 0. If function is continuous at 0 0, then this means that this limit must be equal to 0. Okay. So if we have shown that the value of this limit is equal to 0, which is the value of the function at 0 comma 0, okay, then this means function is continuous at 0 comma 0. So first we will see whether this limit exists or not, then only we can say that this limit is equal to 0 or some other value. Okay. So if we move along, say say y equals to mx, then this is limit x tending to 0 x minus mx whole square upon x square plus m square x square, okay, which is further equal to limit x tending to 0 x square 1 minus m whole square upon x square 1 plus m square, and x tend to 0, this cancels out, and this is equals to 1 minus m whole square upon 1 plus m square, that is depends on m, and since it depends on m, this means this limit does not exist. This means this limit does not exist. and this implies function f, this function f x y is discontinuous at origin, because double limit at 0 comma 0 does not exist. So, we cannot talk about the continuity. So, definitely function is discontinuous at 0 comma 0. Okay. The another example is, say gxy is equals to, it is x raised to power 4 upon this quantity when xy is not tending to 0 0, and it is 0 when xy are tending to are equal to 0 0. That is the value of the function at 0 0 is 0. Okay. Now again we have to check whether this function is continuous at origin or not. So first we will see whether this limit of this function exists or not. Okay. So let us move along two different paths, or let us first move along y equal to 0, say. So if we move along y equal to 0, what is the value of the limit? When you put y equal to 0 here, then this is limit x tend to 0, x raised to power 4 upon x raised to power 4, which is 1. Okay. Now when you move along, say y equal to x square, if you move along y equal to x square, then it is limit x tend to 0, x raised to power 4 upon x raised to power 4 plus x raised to power 4, which is 1 by 2. So from two different paths, values are different. So this means this limit does not exist, and hence this function, so we can say that the function gxy is discontinuous at 0 comma 0, because the limit does not exist, hence the function is discontinuous at 0 comma 0. Now we will see two more examples based on the continuity of function at the origin. Suppose we want to see the first problem. The first problem is fxy is equals to, it is 2x x square minus y square upon x square plus y square, xy not equal to 0 0, and 0 when xy is equal to 0 comma 0. Now again, to see whether this function is continuous at origin, we first see whether the limit, double limit at 0 comma 0 this is a double limit. Okay. Now to check whether this is continuous or not, we have to show that this limit is equal to 0. Okay. Now because if we see different paths, the values always come out to be same, which is 0. So we can check by delta epsilon definition whether this limit is equal to 0 or not. Okay. So this is 0, which is equals to f00 basically. So we are trying to show that the value of limit of the function is equal to value of the function at 0 0 at 0 comma 0. Okay. So how can we show this? So we will try to show you in delta epsilon definition. So let epsilon greater than 0 be given. Okay. So what we have to show basically now, if this limit exists, so we have to show that this is this quantity minus 0 is less than epsilon whenever 0 less than mod x minus 0 less than delta and 0 less than mod y minus 0 less than delta. Okay, this we have to show. So, you take this side, this is mod of 2x into x square minus y square upon x square plus y square. Okay. Now, this quantity is equal to, it is 2x cube upon x square plus y square minus 2xy square upon x square plus y square is modulus, which is less than equal to 2x cube upon x square plus y square mod plus 2 xy square upon x square plus y square is modulus. Okay. Now, this is x into x square, and x square is always less than equals to x square plus y square. Similarly, y square is also less than equals to x square y square. Okay. So, we can say that x square upon x square y square is less than equal to 1. So, it is less than equals to 2 into mod x, because it is x into x square, and x square upon x square y square is less than equal to 1. So, it is less than equal to mod x plus 2 times, again y square upon x square y square is less than equals to 1. So, it is less than equals to 2 mod x. So, it is 4 mod x. Okay. And this mod x is less than delta. So, it is 4 delta. So, if we choose (4) delta is equal to epsilon, then this quantity will be less than epsilon whenever 0 less than mod x less than delta and 0 less than mod y less than delta. So, we have shown the existence of delta for every epsilon for which this inequality hold. Hence, we can say that the limit of this function is 0. Hence, we can say that this limit exists and is equal to 0, which is the value of the function at 0 comma 0. Hence, we can say that function is continuous at origin. So, this implies f is continuous at origin. Okay. Okay. Because this limit exists and is equal to 0, which is the value of the function at 0 comma 0, this means function is continuous at origin. Similarly, we can try one more example based on this. Now, this problem we can also show by converting it into polar coordinate system. We can take x equal to r cos theta, y equal to r sin theta, then also we can show that this limit is equal to 0. Okay. Now, you can take this example, it is fxy is equal to, it is y sin 1 by x when x is not equal to 0, it is 0 when x is equal to 0. So, again we will see whether this limit xy tending to 0 comma 0, this fxy is equals to f00 or not, or limit xy tending to 0 0 y sin 1 by x is equals to 0, because when x is 0, value is 0. Okay. Now, again we will try to show this using delta epsilon definition. Now, how can we use it? So, let epsilon greater than 0 be given. So, I will take this side mod y sin 1 by x minus 0. We will take this side fxy minus L. Okay. Now, this quantity is equals to mod y sin 1 by x, which is equal to mod y into mod of sin 1 by x. Now, sin theta is always, mod of sin theta is always less than or equal to 1. So, it is less than or equals to mod y into 1, because mod of sin theta is always less than or equals to 1, okay, for any theta, and this is less than delta. So, if we choose delta equal to epsilon, then mod of sin 1 by x minus 0 will be less than epsilon whenever 0 less than mod x less than delta and 0 less than mod y less than delta. So, we have shown the existence of such delta for which this inequality hold. Hence, we can say that this limit exists and is equal to 0, which is the value of the function at 0 comma 0. So, this means, this implies f is continuous at 0 comma 0. So, we have seen that if we talk about this function y sin 1 by x, so this function is continuous at origin. Okay. We have shown this by delta epsilon definition. So, this double limit, so double limit of this function is 0. Now, if we talk about the iterated limit of the same problem, say we want to find out limit x tend to 0, limit y tending to 0, y sin 1 by x, or limit y tend to 0, limit x tend to 0, y sin 1 by x. Let us talk about iterated limit of the same problem. Okay. Now, if we take y tend to 0 in this for this function, now this is a bounded function and y is tend to 0. So, this value is always 0. So, this is 0. Okay. Now, this is x tend to 0, forget about y, this is x tend to 0. When x tend to 0, then this limit does not exist, because this is basically lying between minus 1 and plus 1, it is not finite. So, this limit does not exist. So, this limit does not exist means the entire limit does not exist. So, we can say that this limit does not exist. Basically, what I want to say from here, you see that these iterated limits are not equal, are not same. Still double limit exists and equal to 0. Why? The reason is simple, because that implication, that double limit, if the double limit is L, then the iterated limit is also are equal and equal to L exist. That implication will exist only when this inside limit exists. Now, here this limit exists, but this limit does not exist. So, that implication does not hold. Is it clear? Because we can talk about the existence of iterated limit only when the inside limit exists. Okay. So, hence here in this example these limits are not equal, still the double limit equal to 0. So, that is all about limit and continuity of several variable functions. Thank you.